Good morning, dear friends. Let's solve winter 23 MCQ paper, IGCSE Physics, component 22. Yeah, okay. So this is actually pretty easy question compared to the other components, 21 and 23. So let's see. So the first question is, which quantity is a scalar quantity? So acceleration is a vector, force is a vector, velocity is a vector. So time is a scalar quantity. We know that already. So option C is the right answer. Next question. A student measures the average speed of a cyclist in a race. Which quantities must she measure? Okay, so she want to find the average speed. We know what's the average speed? Total distance traveled by total time taken. So is there any of these option? Yes, C has the option. Total time taken to complete the race and total distance traveled by the cyclist. So option C is the right answer. Good. Next question. The diagram shows a series of images of a moving object taken at regular intervals. The object is moving from left to right. Which statement describes the motion of the object? Okay, so before going to the options, let's see the motion of the objects. So in the first few dots are placed in equal interval, and then as it goes to right, so the distance between the objects start increasing. Okay, the difference in distance start increasing over the time, which means that the object's speed is increasing or it's been accelerates. Okay, so the object travels at constant speed and then accelerates. Option C is the right answer. So for fourth option, it will look like opposite. Initially, there will be large gap and then over the time, it will be small gap. Yes, okay. Nice. Next question. So option C is the right answer. A plastic ball has a mass of 4 gram and volume of 20 centimeter cube. There is a crack in the ball surface. Okay. The ball is placed in the bath of water. Water leaks into the ball without changing the volume of the ball, and eventually the ball sinks. The density of water is 1 gram per centimeter cube. Which mass of water has entered the ball when the top of the ball is first level with the water surface? So, okay, let's see the question. Let's break down the question. So initially the ball floats above the water. Why it floats? Obviously the density, ball's density will be less than the water's density. So let's see what's ball's density. Density is mass by volume, we know. So the ball's mass is 4 gram and the ball's volume is 20 centimeter cube. Okay. So density will be 4 divided by 20 centimeter cube. So 0.2 gram per centimeter cube. Now there is a crack in the ball. So the water leaks into the ball. So the mass of the ball will increase, but the volume of the ball will not increase. Okay. It's same as before. Now, if the water gets in, the density will increase because density, we can see density is directly proportional to mass because density is mass by volume. Okay. Now, question is what amount of water the mass of the water has entered so that the ball sinks. Okay. Now the density has to come. The density of the ball has to come 1 gram per centimeter cube. Same volume, only the mass is increasing. Okay. So what formula we have to use? Density is 1 gram per centimeter cube, but mass of the ball plus some x. X is the mass of the water that enters. Okay. This must equal to 1 gram per centimeter cube. So maybe we can rewrite this equation for x. So first I am moving this denominator 20 centimeter cube to that side. 1 gram per centimeter cube into 20 centimeter cube. So this 20 centimeter cube, there is a centimeter cube, and 1 gram per centimeter cube, both will cancel out. So I will get 20 gram is equal to 4 gram plus x gram. I can rewrite this for x gram. 20 minus 4, which is 16 gram. We have that in option. Yeah, option B is right answer. Nice question. Okay, let's move to next question. A satellite orbits the Earth at a constant speed in a circular orbit. Which statement is correct? The resultant force on the satellite is zero. Resultant force on the satellite is towards the Earth. Resultant force satellite away from the Earth. Resultant force on the satellite is in the direction of its motion. Okay, so it's a circular motion. For any circular motion to exist, there should be a centripetal force, meaning that the resultant force is towards the center. Okay, so the option B is right answer. The resultant force on the satellite is towards the Earth. Earth is in the center and satellite is orbiting the Earth. Yes, it's a circular motion. Okay, let's see the next question. Option B is the right answer. The diagram show four identical objects. Each object is acted on by only the forces shown. Okay, there is no external forces apart from this. Which diagram shows an object in equilibrium? Okay, so before that we have to know what is the condition for equilibrium. No resultant force, no resultant torque. So this is a condition for equilibrium. Okay. Okay, let's see which of these options doesn't have no resultant force and no resultant torque. So let's look at the first option. Two 10 newtons are acting on the top, one 20 newtons acting on, sorry, two 10 newton acting upwards and one 20 newton acting downward. But the 20 newton is acting downward to the right side. Okay, so only the 10 newton above will cancel, remaining 10 newton will be there. So this object A will have a clockwise torque. Okay, so this has a torque, so this is not in equilibrium. Let's look at object B. So we have two 10 newton, meaning 20 newton working upwards and then 10 newton downwards. So the resultant will be 20 minus 10. So we will have 10 newton upwards force. So this is 10 newton upwards resultant force. So this is not in equilibrium. Let's look at option C. So option C has 10 newton upwards and 10 newton left and 10 newton right. So this 10 newton left and 10 newton right, they are in equal and opposite direction. So they will cancel out each other. But this 10 newton upwards doesn't have a counterpart. So the resultant force is 10 newton upwards. So this is not in equilibrium. Let's look at option D. So the 20 newton, option D has 20 newton upwards and 10 newton plus 10 newton downwards. So 20 up and 20 down. And this 20 newton is exactly in the middle of two 10 newtons. So they will cancel out each other. So no resultant torque and no resultant force. So option D is the right answer. So option D is in the equilibrium. Okay, let's move to next question. Nice. A resultant force F accelerates a car of mass m along a straight horizontal road from the rest to a speed v in time t, giving it momentum p. Which pair of relationship for this situation is correct? Okay, they are asking relationship between momentum, mass velocity and force and momentum. Okay, so we know that momentum p is mass into velocity mv, and then also change in momentum, which is called impulse. Okay, so ft equal to mv minus mu. So this is what we call change in momentum. So this is equal to momentum p. Okay, even though if it is change in momentum, it's still a momentum. mv minus mu is a momentum. So do we have any of that in equation? Yeah, option C is the right answer. P equal to mv and ft equal to p. By the way, this ft is called impulse, force into time. Okay, let's move to next question. The diagram shows part of a roller coaster ride with the car at different positions. The car runs freely down from position X to position Y up the hill on the other side. What they're asking, what happens to the energy in the kinetic store and the gravitational potential store of the car as it moves from position X to position Y? So they're asking what happens to the energy in the kinetic store and the gravitational potential store, meaning that how much energy stored in that body. That's what they're asking. Okay, uh, let's look at this energy, both energies. We know that energy is conserved. Okay, so in position, let's look at the car is not moving, the kinetic energy is zero, the potential energy is maximum. Okay, when this car slides to position Y, the car will be moving at its maximum velocity, the potential energy will be zero and the kinetic energy will be maximum. Okay, so when it goes from X to Y, okay, the potential energy from maximum to zero, so it's decreasing, and then the kinetic energy from zero to maximum, so it's increasing. So the kinetic energy is increasing and potential energy is decreasing. Do we have that an option? Yes, option C is the right answer. Kinetic energy in store increases, potential energy in store decreases. Nice. Let's move to next question. A box is initially at rest at the top of a rough slope. The box slides down the slope. The weight of the box is 20 Newton. The slope is 4 meter long and 2 meter high. The box does 10 joule of work against friction as it slides down the slope. What is the speed of the box as it reaches the bottom of the slope? Okay, so this question is like more or less uh, like previous question. Okay, but we just have to find the values. Yes. So initially, what happened? The box is in the top and it has a potential energy. Okay, what will be the box potential energy? We know that potential energy is mgh. So mg is 20 Newton, that's the weight, and h is 2 meter. So 40 joules it has. So it has 40 joule potential when it's in the top. Then what happened? It's slide down. This potential energy will be converted into kinetic energy, but not all this potential energy is converted into kinetic energy, because a box does 10 joule of work against friction as it slide down the slope. So this 10 joule from the potential energy is not converted into kinetic energy. It lost as a friction. So the kinetic energy will be 40 minus 10 joule, which is 30 joule. So at this position, at this point, the kinetic energy will be 30 joule. This 30 joules is half mv square. Okay, what they're asking is what's the speed of the box, right? So what connects speed of the box and the kinetic energy is half mv square, which is equal to 30 joule. Now we just have to rearrange this equation to find v square. So v square, it will be 2 into 30 divided by mass of the object. Mass of the object is nothing but 2 kilogram. Okay, so we will be 2 into 30, 60 divided by 2. So square root of 30 meter square per second square. And if you take the root, it will be, sorry, 5.4 meter per second. Do we have that an option? Yes, option A is the right answer. Okay, let's move to next question. An electric car is charged overnight, 8 hours. In 8 hours, okay, 180 megajoule of energy is transferred. What is the power of the charger? Okay, so we know that power is energy by time. So energy is given in 180 megajoule. So this mega, yeah, we will convert into 10 power 6. So 180 into 10 power 6 joule divided by, it gives in 8 hours. Okay, so we have to convert that into seconds. SI unit of time is second. So 8 into 60 into 60. So if it does the work, we can 180 by 60 is 3. Okay, we can cancel out and then we will get approximately 6.2. Okay, yeah, so 6.25 kilowatt. So you can round that off to 6.3 kilowatt. Okay, by the way, there is a caution here. If you don't convert this 8 hours into seconds, you will get one of this answer like 23 megawatt or something. Okay, so we always have to use the units in SI units. So you have to convert the hours into seconds. Next question. An object is a depth h below the surface of a liquid. The pressure due to the liquid at this depth P. What is the pressure? Okay. The gravitational field strength is G. What is the density rho of the liquid? I'm sorry, they are not asking the pressure. Object is depth h below the surface of a liquid. The pressure due to the liquid at the depth is P. The gravitational field strength is G. What is the density of the liquid? So we know that what's the pressure underwater under any liquid is rho GH. The pressure is rho GH. We have to rewrite this equation for density, that's all. So rho will be P by GH. P by HC. I think D, option D is the right answer. P by HG. Okay, let's move to the next question. Brownian motion is a random motion of particle. In which states of matter is Brownian motion observed? So let's think what's Brownian motion first. Small particles, okay, random in their random motion, hit the big particles. Okay, like air molecules hitting the smoke particles, or in a small liquid, okay, liquid particles hitting the dust particles. So these particles goes in a random motion, okay. This does not happen in solids because solid particles are fixed in the axis. It's called lattice. So Brownian motion is observed only in gases and liquids. Okay. So option B is the right answer. Yes. Let's move to the next question. The volume of a fixed mass of gas is varied. The temperature remains constant. Which graph shows how the pressure P of the gas varies with volume V? So do we know any relationship between PV and the temperature? Yes, we know that PV is proportional to T temperature. Okay, for a constant temperature, this V goes to that side as inverse. So P is proportional to 1 by V. So the graph P between P and 1 by V should be a straight line diagonally. Option D is the right answer. Yes. Remember, if it is P versus V, the graph should look like this. That's the right answer. Okay, so since this is P versus 1 by V, the graph look like this. Nice question. Okay, let's move next. Liquid evaporates from a beaker. What happens to the temperature of the remaining liquid, and how does this temperature change affect the rate of evaporation? Okay, so we know that if evaporation happens on the surface, high energetic particles leave the surface, taking the temperature from the liquid. So the liquid temperature will decrease. Okay, and this rate of the evaporation depends on what is the difference in the environment temperature and the liquid temperature. If the difference is so great, it will evaporate faster. If it is very less, it will evaporate slower. So temperature will decrease, and then since temperature decrease, the difference in temperature between the environment and the liquid also will decrease. So the rate of evaporation will also decrease. So option A is the right answer. Good. Thermal energy delta E is supplied to an object of mass m, which does not change its state during the heating process. The temperature of the object rises by delta T temperature. Okay. What's the specific heat capacity of the object? Okay. What is the specific heat capacity? We know the equation delta E equal to mc delta theta, or C equal to delta E by m delta theta. So what's specific heat capacity? The energy required to increase the unit mass temperature to unit degree. Okay, so that's specific heat capacity of a material. So in general, what's the ratio to energy, increase in energy and increase in temperature with the mass of that object? Okay, so if you just rewrite this equation, we are getting C delta E by m delta theta. Do we have any? Yes, A is the right answer. Okay, a room is heated by a radiator. The diagram X and Y shows the two possible circulations of hot air which heat the room. Okay, which diagram and reason explain the heating of room by convection? So what happens if you put a heater? Okay, let's say that we are heating some place, then the air density in that place comes little less because because of heating, the particles will vibrate faster, they will move away from each other, they will occupy larger volume. Okay, so the density will decrease. So if the density decrease, they will go up. If they go up, to fill that place, air from the bottom will come up. Okay, so the airflow will look like this, and because the air density decreases when air is heated. So diagram X, and air density decreases when air is heated. Option A is the right answer. Yes, okay, and this will occur only until every point in the room comes to the same temperature. After that, there'll be random motion only. Yes, okay. A student write down some facts about two transverse waves. Wave 1 has a frequency f and velocity v. Okay. Wave 2 has 4 times the frequency of wave 1 and traveling at 2 times velocity of the wave 2. What is the wavelength of wave to in terms of frequency and velocity? Okay, this look like a competitive exam question. So which connects velocity, frequency, and wavelength of a wave? V is lambda into f. So what we have to find? Lambda. Lambda is V by f. So let's take V and f for the frequency, velocity and frequency of first wave. So we'll take this. We have to find the lambda of second wave, so that we can call it as lambda dash. Okay. So lambda dash wave twice the velocity. So 2v, 4 times the frequency. So 4f. So it's 2v by 4f. Okay. So velocity by frequency. Velocity is 2v, frequency is 4f. So if we cancel out, we get 1 by 2f, or velocity, sorry, v by 2f. So option D is the right answer. Yes. Okay. Straight wavefronts on the surface of a ripple tank approach a gap in the barrier. In a barrier, the diagram shows how the wavefronts change the shape as they pass through the gap. Okay, straightforward. Straight wavefronts bar. Okay. What is the name of this effect? Oh, that's all the question. So name of this effect is, we know, diffraction. Okay. Light travels from air into glass. What is the relationship between the refractive index n of the glass and the angle of incidence I and the angle of incidence, so angle of refraction r? Okay, we know directly from n equal to sin I by sin r. There is one more formula also, n equal to 1 by sin c. So c is critical angle here. So here they are asking only relationship between I and r. So option C is the right answer. Okay. Which diagram shows the image correctly formed by a reflection? So reflection will happen only left to right, not up to down. So object A does not reflect at all. Object B reflect both. No one, yeah, only up to down. So option D is the right answer. If you just appear in the mirror, it will look like this. Yes. A student passes parallel rays to parallel rays of a light through 4 different converging lenses. He measures the distance x and y. So x is the lens height, and y is what's the distance between the lens and the focus point. Okay. Which lens has the longest focal length? Okay. So longest focal length is what is the distance between the lens to the focusing point, which has the longest focusing point. So which has the longest, y is the longest focal length. 3.11 is the longest in the given table. So option B is the right answer. Okay. So we don't care about the x. Okay. What's the horizontal length between lens and the focus point? That's all. Okay. The frequency of the microwaves used in a microwave oven is 2400 megahertz. What is the wavelength of these microwaves? The same formula as we used in the earlier question, which connects wavelength. Okay, there is one more quantity is not given, but we have to take it for granted because the speed of the electromagnetic wave is 3 into 10 power 8. So V is F into lambda. They are asking the lambda. So it's V by F. V is 3 into 10 power 8 divided by F is this mega. I just put it in 10 power 6 hertz. 2400 into 10 power 6. So 3 divided by 2400. So it's 0.15 meter. Yeah, option A is the right answer. Or if you know the spectrum which comes in this uh, wavelength range, is microwave. That way also you can answer. Okay. Which row gives typical values for the speed of sound in a solid and in gas? So this value we have to remember, what's the speed of the sound in air, steel, concrete. Okay, concrete. So whichever densely packed, sound will travel faster than that. So sorry. Option B look like sound in the air is 3, sound in the solid is 30, but it's not that small difference. Okay. Option D is the right answer. Sound in the gas is 300 and sound in the solid is 3000. Only if you know the sound in the air, you can answer this question, because only 1/300 option is there. Meter per second, by the way. A hard magnetic material can be used to make a permanent magnet. A soft magnetic material can be used to make a temporary magnet. Which row shows whether iron and steel are hard or soft magnetic materials? Okay, first, what's iron and what's steel? How do they define soft and hard? So soft and hard comes to what percentage of carbon is there in the metal. Okay, so soft means less amount of carbon. So iron is soft, steel is more amount of carbon. The percentage will be little higher. Okay, so iron is soft and steel is hard. C is the right answer. And if you do not know this question, there is a question 31 in the later. There they have mentioned soft ion is used to make a electromagnet. From there you can answer this question. Yes. So sometimes one or two questions are linked, so you can get answer from another question. Yes. Okay. C is the right answer. A power source is connected to a resistor XY. In which direction are the conventional current and the flow of free electrons through the resistor? Okay, so conventional current is a term coined before the understanding of electron and the flow of current. Okay, so it was considered conventional current goes from positive to negative. So it goes from plus to minus through Y to X. So conventional current will be Y to X. So option C or D. And then the electron will flow from negative to positive. So that will go from X to Y. So option C is the right answer. Okay. Which unit is used to measure the electromotive force? What is the unit of e.m.f, electromotive force? C is the right answer. The graph shows the current voltage characteristics of a filament lamp. Which statement describes how resistance of the lamp changes as voltage increases? This is decrease to zero, decrease but not zero, increases, remains constant. Okay, the resistance increases actually. So the resistance increases as because for same, okay, for same current in the end, you will need more and more voltage. Then where does this energy goes? Then this energy is converted into heat. From that only we are getting light. Okay. So the C is right answer. The resistor increases in a filament lamp. Okay. In the diagram, rod R is suspended from an insulating thread. When a positively charged rod Q is brought close to rod R moves away from rod Q. Okay, which conclusion can be made from this option? So when positive rod Q brings near to the rod, then it moves away, meaning that its repulse. We know that like charges repel each other, so the charge of the R also should be positive. So B is the right answer. Rod R must be positively charged. Okay. So let's look option D. If it is uncharged, it shouldn't have moved. Okay. The circuit diagram shows a circuit used to run a DC motor from AC supply. Which graph shows a current in the motor? Okay, first we do not need to look at the circuit because we are trying to run from AC to DC. So in the DC, all the waves should be positive. So we have B, C, and D. And if you look closely, this is a circuit of a full wave rectifier. So option D is the right answer. But in higher grades, option D will be the right answer. In AS and A level, you will understand what's the role of capacitor in the full wave rectifier. But as of here, D is the right answer. So only positive sides of the wave. There is no negative side of the wave. It's been converted into positive. Yes. The circuit shown can be completed by inserting components at X and Y. The completed circuit is a potential divider in which the potential difference across component Y increases when the temperature increases. Which row shows the component X and Y? So, okay, it's a potential divider. Component across component Y, the voltage increase should increase if the temperature increases. Okay. When the voltage will increase? When the resistance ratio between X and Y. When X is higher than Y, sorry, Y is higher than X. The resistance of Y is higher than X. In that case, the voltage across the Y will increase. So we have LDR, resistor, thermistor, but we have to increase this voltage when the temperature increases. In our syllabus, we have NTC, negative thermal coefficient temperature. It's a thermistor. When the temperature increases, the resistance will decrease. So that we have to put it in X. And Y we can use a fixed resistor. So when temperature increases, the X resistance will decrease so that the Y's potential difference will increase. So X is thermistor, Y is resistor. Option D is the right answer. Okay. A piece of soft ion. See, in this question they have used soft ion coil wire. So they are using the soft ion something like electromagnet. So we can answer there soft ion. Okay, let's come back to this question. A piece of soft ion XY has a coil of wire wound to around to it. The N pole of a bar magnet is pulled away from end X, which causes an induced current in the coil. The magnet is now turned round so that the N pole is on the left. It's taken to the other end. Okay, so now they are switching. Soft ion and the N pole is pushed towards the NY. New current is induced in the coil. Which statement is correct? Opposite. Okay, it's about direction and whether it attracts or repel. First, it's going to repel because you are inducing current. Okay, so this attract options we can delete. So we have repel B and D. So initially, the N is moving away from S. So it will give you negative voltage. Next, they are switching. Okay, the N again approaching Y. So it's still the same direction. Okay, so the new induced current will be in the same direction. So initially it was moving away and then you are switching and then moving inside. So it's the same direction. Okay. So the new induced current will be in same direction and it will repel. So option D is the right answer. Yes. Why it should repel? Because induced e.m.f opposes the change in motion. Yes. The diagram shows a wire with wire in the magnetic field between two poles of a magnet. Okay, there's north pole and south pole. There's a wire. The current in the wire repeatedly changes between the constant value in one direction and the constant value in opposite direction as shown in the graph. So it goes for positive and then comes. So it's decaying and growing like this. Okay, or going in the opposite direction. So what is the effect on the wire? Okay, so for this, what's the force on the wire? So you can use Fleming left-hand law. So it gives the force of a motor. Okay, if you supply current, you get a force. So initially from north to south, the field goes like this. Okay, and the current goes like this. So force will be like this. And then the current is switched. So it's going to move up. So force will be like this. So the force on the wire will alternate one direction to the opposite direction. So A is the right answer. If the current changes. Initially the force is like this. Finally the current changes direction. It's like this. So it will oscillate back and forth. Force on the wire alternates. Yes. Okay. A transformer has NP primary turns on the primary coil and NS secondary turns on the secondary coil. The voltage across the primary coil Vp and the voltage across the secondary coil is Vs. What's the relationship between these quantities? These four quantities. Okay, we know the equation of transformer. Vs by Vp equal to Ns by Np. So here Vp by Vs equal to Np by Ns. Option B is the right answer. Nice. Okay. Magnesium ion has a double positive charge and a chloride ion has a single negative charge. Which statement is correct? Okay. So first a chlorine atom gains an electron to form a chloride ion. So single negative charge means you have one electron extra. So the option 1 is right answer. But still you will explore the other why they are wrong. Chlorine atom loses a proton No, the charge does not change from alternating proton. You cannot. It's a nuclear reaction. Only the it has electrons involved. Okay. So 2 is wrong. Magnesium atom loses an electron and form a magnesium ion. But magnesium is positive. Okay, double positive. So you have to lose 2 electrons. Okay, that's wrong. The magnesium atom gains 2 electrons. Then it will be double negative. Okay. So A is the right answer. Which row correctly describes an example of radioactive decay? Okay. So first, radioactive decay will happen only if the element is unstable. So option A is wrong. And only for gamma, the element will not change. For alpha and beta, element will be changing. So option C and D is wrong. So B is the right answer. Original nucleus is unstable. If it emit alpha radiation, alpha is 2He. Okay, so equivalent to nucleus, helium nucleus. So element change will happen. So B is the right answer. Okay. A radioactive isotope of sodium has half-life of 15 hours. The table gives data from an experiment to show how the rate of decay of the isotope varies with the time. The background count rate has not been subtracted from the data, from this data. What is the background radiation count rate? Okay, so this is little different question. Yes, usually they'll count the background rate and they will ask for the values. Okay, how to do that is, so they have given list of background counts. Okay, and we know what's the value initially 0 hour and half-life is 15 hour. Okay, so in the timetable time 0, 10, 20, 30, we can select 30 because that's multiple of a half-life. So 30 hours is 2 times the half-life completed, meaning that the initial value should be divided by 4, 2 half-lives. Okay, for example, initially 100 means first half-life it's 50, second half-life it's 25. This is how like. Okay, so let's try with a different background. Okay, let's try to subtract the background count and then what will be their values. Okay, so that will be after the half-life what will happen. Oh, sorry, maybe I can put this side. Yes, option 20, if you look, so if you subtract 400 from, sorry, 220 from 400, you get 380. Then you divide by 380 by 4, then you get 95. That matches with the given value. 95 comes from 115 minus 20, which is 95. Okay. So by the way, what happens here is 0 hour and 30 hour. From both, I subtracted all the background counts. Okay. And then I calculated the, say, after 2 half-life, what will be the amount, count rate. So that's it, which is equal to our option. Only C is 95 and 95 we have. So C is the right answer. 20 comes. How you can just do in simple steps is look at the background radiation, try to subtract from both 0 and 30. Okay, and try to divide 0 by 4. That should be the value what you have subtracted from 30. So here only 95 matches, so that's the right answer. So option 20 is the right answer. Okay. So what happens in the process of nuclear fission? Nuclear fission is splitting of atom. Okay, splitting the nucleus of atom. So option C is the right answer. There is nothing to do with the electron. So first two options are gone. Two atomic nuclei join together. That's nuclear fusion. Okay. So fission is splitting of nucleus. The time taken for Earth to orbit the Sun is approximately 365 days. The average radius of Earth's orbit around the Sun is 1.5 to 10 power 8 kilometer. What is the average orbital speed of the Earth? Okay, average orbital speed is total distance traveled by time taken. So it's going in the circular path. So total distance traveled will be circumference of the circle, which is 2 pi r by time taken t. Okay, the radius is 1.5 into 10 power 8 kilometer. That kilo also we have to convert because SI unit is meter. So instead of 2 pi r, 2 pi r is 1.5 into 10 power 8 multiplied by 10 power 3 meters. Okay, 365 days I have to convert into seconds. So 365 into 24 day, 24 hours in a day into 60 minutes into 60 seconds. If we do the calculate, we get this, and then the final value is 3 into 10 power 4 meter per second. Option C is the right answer. Okay. Okay. So the sun transfers energy to the earth through electromagnetic radiation. What are the two of the parts of electromagnetic spectrum of which most of our energy belongs? First, we are receiving energy from most of the electromagnetic spectrum. Okay, but of two most parts from which we receive most of the energy will be infrared and visible light. Okay, so radio also still we receive energy, but not that much energy. So infrared radiation and visible light is the right answer. And we get our skin burn, and then we feel the temperature due to this infrared only. So infrared radiation and visible light. Yes. Last question. How does the sun produces its energy? By fusion of hydrogen. Yes. Okay. Okay. See you next time. Bye bye. By the way, if you need to solve any paper, please let me know in comments. Put it in comments so that I'll upload the solutions for that paper. Thank you. Bye bye. 21st century education.